In this lesson, we are going to be adding and subtracting rational expressions. So, the first thing we always have to remember when we're adding or subtracting fractions is that the denominator has to be the same because the size of the piece must be the same in order for us to add them. So if we have 2 over 8 plus 5 over 8, remember we add or subtract the numerators and the denominator stays the same. And then we simplify if we can. That will be the same if we have variables. We add or subtract the numerators, the denominator stays the same. So in this case, 3 take away 7 would be negative 4, and the denominator is 2x. But then we have to check to make sure if we can simplify, so both of these can be divided by 2. So our final answer will be negative 2 over x. In the next example, we have 3x plus 6 as our numerator, and then we have x minus 4 as our denominator. Taking a look at both of those, we can take out the greatest common factor for the numerator, which would be 3, and our denominator can't be factored, so we're going to put it in parentheses. In this case, I could not simplify the numerator and denominator at all, but it's important still for us to factor because there are times when it can be simplified. Now, when we are looking for the least common denominator for a fraction, generally what we've done in the past is multiplied both of the denominators together to find our common denominator. So we'd have 1/3 plus 2/7, and we know that we want a denominator of 21. So what do I multiply by 3 to get 21? I multiply by 7, and if I multiply the denominator by 7, I multiply the numerator by 7. Likewise, what times 7 is 21? That would be 3, so I also multiply the numerator by 3. Then, same thing, we add the numerators together, keeping the denominator the same, 13 over 21. So the same thing can be done when we have fractions that have variables in there. Our common denominator would be multiplying the two together, so it would be 5x. So what number times 5 would be 5x would be x, so we'd have 3x. What number times x would be 5x, and that would be 5. So when we are going to subtract these, we would take 3x minus 10 over our denominator of 5x, and 3x minus 10 cannot be factored, so that would be our final answer. All right, so finding the common denominator when we have expressions of 2x cubed and 4x. So first we say to ourselves, what is the common denominator for just the number values, 2 and 4? So it would be 4. And then if we want our x cubed and our x, our common denominator would be x cubed. It's always the largest amount of the variable. So what do I multiply times 2x cubed to get 4x cubed? I would multiply the numerator and the denominator by 2, and I would get 14. Then for the 4x, to get 4x cubed, we're going to multiply both the numerator and the denominator by x squared. So we would have 5x squared. So when we add, we would put 5x squared plus 14 as our standard form, divided by 4x cubed. 5x squared plus 14 does not have a greatest common factor, so that would be our answer, and that was doing our method horizontally. In the next example, x squared minus x minus 6, we want to factor that first. So when we multiply to get what two numbers multiply to be negative 6 but add up to be negative 1 would be negative 3 and 2. So we have x minus 3 and x plus 2. Now our common denominator would be both of these, x minus 3 and x minus 2. But our second fraction only has the x minus 3, so we need to multiply both the numerator and the denominator by x plus 2. We'll leave it in factored form, but we will multiply and distribute the numerator because we are going to have to combine like terms. So we want to combine like terms. We'd have 5x plus 14 as our numerator, and we'd have x minus 3 and x plus 2 as our denominator. And knowing that I cannot take out any greatest common factor for 5x plus 14, and that would be our final answer. So let's make our x and factor what two numbers multiply to be 12 but add up to be 7 would be 3 and 4. So we'd have x plus 3 and x plus 4. And notice on the second expression that we would have to multiply both the top and the bottom by x plus 4 to get our common denominator. So we have 4 over x plus 3 and x plus 4 minus, and we're going to distribute 5x plus 20 over x plus 3 and x plus 4. Now, when we are subtracting, we are saying by putting this into standard form, it would be negative 5x, and then it will be 4 minus 20. And that's going to give us negative 16. And there is not a greatest common factor, so we'll leave that, and we're going to leave the denominator in factored form. All right, one more, subtracting with unlike denominators. So we have x plus 3 and x plus 3 if we make our x. What two numbers multiply to be 9 but add up to be 6 would be 3 and 3. And then we have x plus 3 and x minus 3. This one is a challenge problem, and here's why. Because we have 2x plus 3's and only 1 here, so we have to multiply both the top and the bottom by x plus 3 in order to get two of these factors to be the same as these two. However, this has an x minus 3 and the first one doesn't. So we need to take both the numerator and the denominator times x minus 3 to get our same factors. All right, so what that means is that we are going to FOIL this top part because we are going to need to combine like terms on the top. So we have x squared, and then we have minus 3x, we have plus x, and we have minus 3. And all of that is over x plus 3, x plus 3, and x minus 3. Then we have minus 1 times x plus 3 would be x plus 3, and the denominator is the same, x plus 3, x plus 3, and x minus 3. So now we're going to combine like terms. So we have an x squared. We have a negative 3x and a positive x, which is negative 2x, and then another negative x. So that's going to be negative 3x. And then we have a negative 3 and another negative 3. So that's going to be negative 6. All over x plus 3, x plus 3, and x minus 3. Now the last thing to do would be to check if we can factor the numerator to see if we can simplify anything. Are there two numbers that multiply to be negative 6 but add up to be negative 3? So that would be 6 and 1 or 2 and 3. And neither one of those combinations will do that. So this is our final answer, and we can put the numerator in parentheses to know that we can't factor that and it needs to stay. So when adding and subtracting rational expressions, you must have a common denominator and then be sure to simplify. So when you're starting on problem number 1, make sure to factor first, and then you will use those factors to find your common denominator. And number 2, we can find our common denominator between 8x squared and 16.